Welcome to Modular March. I'm Andy, this is Robbie, and we are The Rollup.
Modular March is an educational experience about all things modular. Enjoy.
Welcome back to Modular March. Today we have a episode about interoperability from Hart, founder of Across and Uma. Hart, welcome to the show and to Modular March.
Thanks, guys. It's March. It's great. Springtime.
Yeah, I've been getting hated on for it not being Modular March because the market is red, but if you have a time preference of over 6 months, then I think it is Modular March.
I think it's green today, man. It's like people, let's be a little less short-sighted. Let's build for at least the medium term here, right?
Yeah.
Medium term being at least a couple of days.
But anyways, yeah, Andy, Robbie, I'm excited to be here. There's very cool stuff to talk about. I want to go deep on my views on intents and why I think it's the future of Interop. But yeah, how should we do this? Should we just get into it?
Yep, jump on in. Excited to learn.
All right. So please do interrupt me. Let's get the readers. Let's have you guys asking all the questions that the listeners might. But the starting statement of what we want here in this roll-up multi-chain future, we want fast, cheap, secure interop that is so damn seamless you don't even know that you're talking to blockchains. We want them ultimately abstracted away. And so the way I kind of wanted to frame this discussion and where I want you guys to push back is sort of like how people have been thinking about interop and some ideas for how I think we could expand that thinking or maybe course correct it. So the typical view here is that interoperability should look like TCP/IP, like the backbone of the internet. And here I have a fun clip art of like what the internet is supposed to look like, where you have networks and they talk to your internet service provider, and then there's backbone routers that send messages from point A to point B, and they send those messages very quickly. We're recording this podcast over TCP/IP. It's quick and it's cheap. And I think when people think that way, they think bridging should look like TCP/IP. Interoperability should function this way because like sending a message should just be as seamless as sending an email or a DM or something like that. And so the naive way, I think, of thinking about how interoperability should work is you have blockchain A, blockchain B, you send a message between them. But this, I don't think, is quite right. And the reason here is that in blockchains, we are trustlessly trying to send value. And sending messages in a trustless setting between blockchains, sending them quickly, cheaply, and securely is incredibly difficult to do. In my opinion, it's kind of impossible. Maybe not impossible, but it's very hard. And this is something people have been trying hard to do. And there's trade-offs here. Basically, if you want to send something fast, you usually are sacrificing on security or cost. And if you want to send something cheap, you're also usually sacrificing on security. And if you want to send something securely, you're usually sacrificing on speed or cost in some way. Sending a trustless message is just not an easy thing to do. Oh, my clip art. That's supposed to be an explosion. There's a big explosion there in my presentation, but it didn't show up in the GIF here. So like the view here that we have at Across is basically to stop sending messages. It's hard to do. Don't do it. And turns out like we actually can do that for most things. And the observation here is that like in TCP/IP, you are sending unique messages from point A to point B. But in blockchains, we are mostly, not exclusively, but we're mostly moving value between these blockchains. And value is fungible. Like Andy and Robbie, you guys, like if you're gonna send, if I'm gonna Venmo you $200, right? You don't care which $200 I'm sending you. It's not a unique $200. I just got to send you $200, right? And so if that fungibility aspect means there are so many other ways we can send that money, it doesn't have to be my exact $200 that I have in cash and I like ship it to you via like FedEx or something. Rather, somebody else could fill you with the $200 and then I pay them and you guys are happy and you got what happened, and that it works. And this is our mental model for how interoperability should work for most cases between blockchains, where because value is fungible, we can have other actors, we'll get into this in a second, but we can have other actors go and fill the user on their cross-chain transaction with their own funds and then pay them back later. And in doing so, we step away from having to send messages. So here's the diagram. So we had this naive way of sending messages of interoperability where blockchain A is going to send a message to blockchain B. In the across world, in the intent-based bridging world, we don't do that. We don't send a message, at least not initially. Instead, we have a third party. We call them relayers. Other people in the ecosystem call them solvers, market makers, searchers. But this off-chain actor, blockchain A will deposit funds on blockchain A in an escrow account. And then this third-party actor is going to go and fill the user on blockchain B with their own capital because value is fungible here. And so the user is able to get a quick fill, like a really fast fill, simply because of this solver filling them with their own money. Does that make sense to you guys?
It does. It does. On the point of kind of not having messages or general messages, like what are some examples today of not strictly value transactions happening cross-chain?
Sending like governance parameters is a good one. So let's say I'm Uniswap governance and I'm trying to control the governance parameters of a different chain.
Right.
And these governance parameters might be like, if I screw them up, so I'm Uniswap on Ethereum, and I want to control the governance parameters of Uniswap's deployment on BNB, right, or on BSC, on Binance Smart Chain. Okay, well, if I screw up these parameters, maybe there's like billions of dollars at risk that could get screwed up. And so like these are specific non-fungible instructions that I need to send to this other chain. And that's an example of something that you can't fill with intents. Like you need to transfer a message securely between Ethereum, where Uniswap voted on what the parameters are, and BSC, where they're going to get implemented. So that would be like a good example of something that is that requires it can't be done with this approach. But in the other examples where if I'm trying to execute a transaction on another chain where all I need to do is pay, 5 BNB to do so, right? That could be done with the intent framework because I can just transfer the value to pay for that transaction. Does that make sense?
Yeah, it does. Is that not enough to debunk your thesis? Is $1 billion governance vote not enough to kind of prove that general message has a place? Or you're kind of saying for the majority of transactions, they're value driven, we should use intents, and then for specific cases, trying to figure out a general message passing platform which kind of achieves those three things simultaneously is the next best thing?
Well, okay, two riffs on this. There is definitely a place for generalized messaging. Like we need that, without a doubt. Two arguments though. One, I don't believe that general message passing actually needs to be very fast. I think it needs to be maximally or necessarily very cheap. I think it needs to be very secure. So I
Yeah.
think in that general message passing, we need to be able to send those messages very securely between chains. And, that's like, again, if Uniswap governance had to pay $5,000, like some big number, to securely send the messages from their governance on Ethereum to BSC, and they could take 2 days doing it, they'd do that. And they would happily pay that $5,000 and happily take 2 days if they were really, really sure that message couldn't get corrupted, because there's like billions of dollars at risk on the other end. So that makes total sense to me. So there is a need for generalized messaging, and there's more examples than just this. But to your other point, my belief is that 95 to 99% of what we need to do between blockchains is around moving value. So most user activity is going to be around moving value in some way, shape, or form. So I think if I'm going to be a little bit spicier, yes, we need generalized messaging. However, I think value transfer is like the killer app of generalized messaging, and it's actually where the value is going to get captured. It's where it's
those don't really compete with this model. I mean, sometimes we have some issues with intent-based mechanisms where there's too much demand or fillers aren't filling in on one set of chains, and you have some weird waiting times. But for the majority of time, it's the security, cost, and speed of an intent-based design basically outweighs any sort of value transfer that would be needed to be made on a general message passing protocol, thus making from the user's perspective, it's like a little bit of different, but from like a higher level research perspective, it almost seems like doing value transfers on GMP based bridge designs is almost useless.
The other example here, if we're going to analogize this to traditional banking, I don't think I'd want to use Venmo to send $1 million. Seems a little risky, right? Or slow, and they don't let you do it. Venmo is not designed for that, right? But I also don't think I want to send an international wire transfer to send $200 either, right? So there's a lot of Venmo transactions that go through, and relatively few international wire transactions. They have different markets here, and I think that's an example. So intent-based bridging, and I think you can do a lot more than Venmo. I think you can go to pretty large scale, but it's for quick, fast, and very secure value transfer of sizes sub $1 million or $2 million, let's say. And beyond that, maybe you look for a different solution. Okay, to keep going. So this was my slide earlier. With cross-chain intents, we have these third-party actors. We call them relayers, but they fill users with their own capital quickly and cheaply, and then they get repaid later. And so if you think about what this kind of our view of this stack looks like, we have 3 layers here. We have the intent layer, where the user specifies what they want to do. So Robbie wants to bridge 200 USDC from Optimism to Arbitrum. He writes his order, his intent. Then we have solvers that compete to fill Robbie's order. And then we have the settlement layer. Because as we said, the solvers fill Robbie with their own money. Robbie's money is actually escrowed on the origin chain. And then the settlement layer verifies that intent was fulfilled. Like the user gets filled quickly, then they don't really care. The user doesn't really care about the settlement layer, but the settlement layer holds the user funds in escrow and repays the solver after we verify that the intent did in fact get filled.
Can I interrupt you there?
Yeah.
So when I submit my intent to the origin layer or the origin chain, does that not generate a message? Whether that message contains value or it's a generic message, does that not indicate to this or send something to the solvers letting them know that I'm trying to get filled on the destination chain?
So we should be specific here. If you submit your intent on the origin chain, you've made, in the across system, you've made a deposit transaction. So you've just done a transaction on the origin chain, which makes sense. You got to deposit your money somewhere. And in our design, all the solvers are listening to the origin chain because it's a decentralized consensus mechanism with like this mempool or centralized sequencers or whatever. So they're listening to the origin chain, and that deposit action is the signal that you, Robbie, want to move assets from A to B, right? And so then they race to fill you on the destination chain, but there is no cross-chain message that gets sent. You only did an action on the origin chain.
Got it. And then these watchers that are off chain, there's no they're the ones that okay. I think that makes sense. Okay, and then I have a bit of a separate question, which is that across is the settlement layer here. And if we're settling transactions to across, does that mean across has its own ledger, like its own state? And if so, does that make across a rollup or some sort of its own blockchain?
Or like an L1, depending on the definition.
If not, why not? What is it missing to be a blockchain?
All right, so remember all the annoying crypto Twitter debates about like what is a roll up and like everything's a roll up or nothing's a roll up or something like that? Maybe we could talk about this here too. But what Across is doing as a settlement layer again is it's escrowing funds and then verifying that the solver did fill the user and then releasing those funds. So there is definitely accounting and like state embedded in Across where we can see, okay, yeah, Robbie's deposit transaction went into the Across escrow contract on Optimism, if that's your origin chain. And then we can also see that the solver, let's make Andy be the solver. Andy filled Robbie on the destination chain, which was, in this case, Arbitrum, right? And we can see that on the Arbitrum blockchain, and it routes through the Across contract on the Arbitrum blockchain too. So between what we have in the Across contract on Optimism and in the Across contract on Arbitrum, we can verify that that intent was fulfilled. So there's definitely accounting in Across there. However, it's not its own roll-up because your deposit transaction was not written to a separate chain. It was written to the deposit chain itself. So there's sort of a way that you could abstractly think, and there's many actually useful analogies to how you could think about Across the settlement layer as something of a roll-up, but very, very, in the purest sense of the word, it's absolutely not. It's just literally doing accounting on these deposits and fills between chains.
Yeah.
Okay. So the advantages of intents. Intent 1, intents can be really fast. So here's some of the data we have on Across versus like other message-based bridges. I'm not picking on Stargate, although I sometimes do, but Stargate's up here. And then Circle's CCTP is also up here too. And these systems send a message between blockchains or do work between blockchains to fill users. And so Across here is much, much, much faster because solvers actually don't have to wait for finality on the origin chain to fill users. So it's actually worth explaining what I mean by that. Like, and maybe Circle CCTP is a good example where if you make a deposit on, like, let's say Arbitrum, or we'll keep going. Optimism is the origin chain, Arbitrum is destination chain. We'll use that for the talk. But if I make a deposit on Optimism through CCTP, Circle is going to delete that USDC and then mint it on the other side. And if that deposit transaction gets screwed up in any way, Circle might literally just like lose money or delete money. It'd be very bad. So Circle doesn't want to trust the Optimism sequencer when it says this deposit went through. It can't afford to do so. It actually doesn't even want to trust the first checkpoint. It wants to have finality on Ethereum that this transaction did in fact go through before it's going to allow the USDC to get minted on Arbitrum, because otherwise you could like be deleting money.
And Hart, real quick, that takes 7 days, that finality.
So here's where Circle is, I think, intelligently doing things. They can actually go and recompute and see if there was a fault in optimism. And so I think they probably are doing this because they're good at what they do, right? They can actually see, they have all the information to know if the state transitions were valid within like a checkpoint, right? So they don't need to wait the 7 days technically. There's a little nuance there, but they need to at least wait for that optimism deposit to be checkpointed into Ethereum, and then for Ethereum to achieve finality on that. And that's why they take about 20 minutes to do so. And that's all just even though the risk of there being a reorg on optimism through there is extremely, extremely small, they like just can't afford to mess it up if it was like a $5 million transfer. So across is different because we basically have these solvers that are filling users with their own money, and they're doing it for a small fee. But these solvers, if Andy's the solver here, Andy can go and be like, yeah, you know, there hasn't been a 3-block reorg on Ethereum in like forever. And the risks of that reorg, or actually, sorry, we're going from optimism. Andy could just be like, I trust the optimism sequencer. Optimism's not going to lie to me on this $10,000 deposit that Robbie made, or this $200 deposit Robbie made. The probability of that is basically 0. And so Andy can be like, as soon as I see the pre-confirmation on optimism, I can go and fill Robbie on Arbitrum, right? And that ability for relayers to take some very small finality risk, but like they can take on some finality risks, means across can be extremely fast in filling users across chains.
Yeah, I mean, I've had transactions like ETH to Arbitrum like less than 5 seconds. I know that you're saying now with EIP 444, Denkun, whatever you want to call it, it's less than a cent and sub 5 seconds transactions. So I've definitely had some really, really fast transactions on across, and which now kind of made me a believer in the intent system. But intents can also be really slow if the fillers are busy, or if the fillers have run out of money, or they have other opportunity costs for filling somebody else's order with a different kind of better upside. So why does that happen? Like, why are sometimes fillers busy, or are like, what's the motive there, or the incentive?
Yeah, I mean, these are like good questions, right? So this intense system relies on these off-chain actors to make user fills quickly. If the off-chain actors don't show up, then we have a problem. So
yeah, they have the smoke break.
yeah. Now, to be clear, like users aren't at risk. They can get their funds back, or they'll get filled a little bit slower, right? So I actually think it's important to say that the problem here isn't a security problem. It's like a speed guaranteed problem, right? And generally speaking, like it's not any different than particularly before the merge, trying to have your transaction included on Ethereum, just on Ethereum L1. Like if there was a lot of congestion on the network, you either had to pay higher fees or wait a while, right? It's like, okay, that happens. And so generally speaking, the issue is if a filler or relayer solver is not showing up to relay these transactions, it's because at that time, they're not getting paid enough to do so. So you got to pay them more or wait a minute. And I think that like, yeah, there'd be something nice if we could always guarantee like a sub 5 second fill. That would be really cool. But I don't think that's possible. So instead, what we can do is like 99.9% of the time guarantee a sub 5 second fill for modest size, and just try to be really transparent with the users, which we try to do in the across UI, about what they should expect.
Yeah, I mean, it definitely is it's like more than 9 times, like 95 out of 100, if not more. So just to kind of work it under the hood, are these fillers? Are they typically running like a automated system, where like the liquidity is just kind of moved around based on like some program that they have?
Yep. No, this is great. Anyone listening, if you actually want to make some okay returns, go to docs.across.2, go to the developer side and look at running a relayer. We have the code ready for you to do it. You can go and run a relayer. It's cool. Relayers are competitive. So like they're actually doing really intelligent things to fill users quicker, which is kind of cool, right? So it's a competitive business, but it's still like reasonably profitable, actually quite profitable, and anyone can do this. And we have like the reference implementation of a relayer that anyone can go download and run.
What are the capital requirements to be competitive as a relayer?
So this is interesting because like, as you guys maybe make sense, we didn't necessarily predict this, but there's more competition at smaller size because it requires less capital to fill users at smaller size. So there's less competition at bigger size, but you need to have more capital to do so. Kind of makes sense. So capital requirements are not large. Like, I mean, you wouldn't really be able to do this with much less than like $10,000 type thing, right? But the capital requirements aren't large. It's just, you know, you become limited in terms of the volume and size of transfers you can fill.
Makes sense.
Okay. Second advantage of intents here. So we'll go like a little bit technical for a second, but maybe we'll keep it high level. Intents can be really secure. And the observation here is if we go back to the trade-offs between being fast, cheap, or secure, what this whole intents architecture has done is it's separated the urgent part from like the complex part of the interop problem. And so in the urgent part, we just talked about why a user wants like a really freaking fast fill. And we're able to give that to them because these solvers are competing to fill users. And they do this without sending any message whatsoever. The complex part is how we like securely message between blockchains, right? That's the hard thing to secure. But because like across separated these things, because the user already got filled, we can actually take our sweet time and actually spend a lot of money securely verifying that the user was actually filled. And this looks a little bit like general messaging, right? Because now we're talking between blockchains and looking up and seeing what happened. The way Across does it is through some batching that I'm going to go into in a second. But generally speaking, the core observation here is that once we've done this intent thing, we're able to kind of break this trilemma. We gave the users their fast fills. So now we can figure out how to verify that with time, with the advantage of time. And the ways we can verify this fill are like pretty broad, right? We could do this by sending messages over the canonical bridges that the rollups have, which are extremely secure because they're canonical. But if we're coming off of a optimistic rollup, it might take 7 days. We can secure them with ZK proofs, which is becoming more and more realistic, although we're like not quite there yet in terms of every use case. And we can also use optimistic systems, which is what Across does, where we can say, hey, here's what fill happened, or in Across's case, we batch this together. Here are the set of fills, and anyone can disagree with them. So Across has this like one honest disputer assumption, which I think is a really, really reasonable trust assumption here. But we can, it's slow. Optimistic verification is slow, but we don't care because we've already filled the user. So this is the advantage of like why Across is allowed to be really secure. The third advantage is that intents can be really freaking cheap. And this, I don't know if the listeners or viewers will be able to see the screenshot, but here we have average Across speeds, again, against Stargate and Circle CCTP. This is all pre 4844. So now Across speeds L2, L2 are literally like 1 cent. It's 2 orders of magnitude cheaper than we're showing here. So it's extremely cheap. But the reason why Across is so cheap here is because sending messages with every bridge transaction is expensive. It just costs a lot of gas and or security to send messages back and forth. And Across has this innovative way of actually batching this together. So we can do 10,000 bridge transactions where Andy makes 10,000 small loans and then verify that all in one batch and spend amortize the cost of verification of those 10,000 bridge transactions into like one message, if you will.
Are you sure Cross doesn't enroll? No, I'm just messing.
The batching stuff does make it look roll up like. So I was gonna to Robbie's point, it's not a roll up in how it operates, but the ability to batch together, like the same way L2s batch together transactions and then check them into Ethereum, that concept does apply to Across, where we're batching together the verification of these intents and then verifying them in batches. And so that part does look, it has analogies, it's analogous to how rollups work in some sense. The trade-off here is that if Andy did, in my example, Andy did like 10,000 fills before getting it repaid, like he has a cost there where he made loans on those 10,000 fills. And so that trade-off matters. But here's where I kind of want to go into the sort of math and the concepts behind this. And I'm trying to put a theoretical example that's pretty realistic. So Across is routinely bridging around 50 million bucks in volume a day. And we're doing that over something like 25,000 bridge transactions. So what does this look like in terms of our verification costs? Well, if I make a 1 hour loan, so if on average, solvers are making a loan for about an hour, maybe two, a 1 hour loan at a 10% annualized interest rate on $50 million is $500. It's a small amount of money because it's a small amount of time. And then if I'm saying 150 canonical messages, if I do 150 verifications over a day, this is a bit abstract, but this is conceptually kind of what Across is doing. I might spend $2,000 in gas and security on those 150 cross-chain messages. So my entire kind of security costs for Across here are like 2,500 bucks, right? Whereas if I needed to send a message for each of those 25,000 trusted messages, here I'm saying sending those messages cost $2. Post 4844, it's cheaper than that. But the point is, it's a real cost. It's there's security costs in sending those messages. I have a much, much, much higher cost for sending a message between blockchains every time I do a bridge transaction. So sort of theoretically, intents here with the batching concept can just be very cheap relative to alternative designs.
I've got a value accrual question.
Yep.
We brought up this idea of where value accrues in the modular stack to Tarun from Gauntlet, which is the video we posted today. And I think we agreed that value accrues to the users. And I think he made the point that it does so through tokens. So when we're looking at this combination of general message passing or canonical message passing as the slow path, and then intent layers as the fast path, where do you see value accruing? Do you see it accruing to the slow path, or do you see it accruing to the fast path, or both, or neither? How do you hash that out?
So my spicy take is value does not accrue at the general messaging layer, because literally looking at the slide, instead of sending 25,000 messages, I'm sending 150, something like that. So if I'm saying I'm offering you a better value transfer experience, but I'm sending basically my world is we can have billions of cross-chain transactions happening, but we're sending a few hundred messages between blockchains. So I don't think value is going to accrue at the general messaging layer. Do I think value can accrue at this intent-based fast messaging layer? I think yes, but I also think it's pretty efficient. Like, I don't think this is the sort of thing where we're going to be ripping users' faces off. It just won't happen that way, right? And like, generally speaking, guys, this is the beautiful thing about blockchains. Like, if you insert too big a moat around anything, if you try to charge too much, people are going to take their business elsewhere. It's like hyper competitive that way. But let me see. Well, this is actually kind of the point I was going to make in the next slide. But if I go to like this slide, if a cross is functioning as a settlement layer that enables these cross-chain intents, I do think that as the settlement is cheaper and more efficient than the other settlement layers out there, a cross can charge a modest fee at that layer and pay it to token holders, the Across token holders. And this is actually how Across's like token economics are designed. They look a lot like Uniswap's, where there's like a fee that can get turned on by governance that would charge a small, like a couple bips of the value flowing through this settlement layer. And that money could go to, would go to Across token holders. Yeah.
Quick question on that, which is that like, there's an article out there by the founder of Zora, and it's called Hyperstructures. And one of the parts of that article is that just the threat of the fee switch is enough to make that protocol valuable, even if that fee switch is never turned on. Does it have that fee switch turned on now? And if so, why? If not, why not?
So it does have the fee switch built into the code. It is not turned on. We haven't turned it on because bridging is competitive and it's still nascent. And we want to establish our position better. We don't want to be charging fees too early, I think. That's my view. Again, this would be voted on by governance, but I would personally think it's too early to turn this this fee on. And so, yeah, like the idea, I am a little bit more of like a boomer TradFi guy in the sense that I think for things to accrue value, they ultimately have to charge fees. I spent a lot of time thinking about though when they need to charge fees, and it might not be for a long time in the future. But like, I really do, having like studied and been close to the Uniswap team for a long time, I think their whole path is right. Like the Uni token, for a while there, people have gone back and forth in terms of whether they believe it will accrue value. And now that they're talking about the fee switch again, people are more like, that was the 50% up move in the Uni token. People kind of were reminded, oh yeah, shit, we could turn on a fee here and it'll capture value, right? So I see both sides of it, Bobby.
Cool. And to close the loop here, on the value accrual point, I just want to go just to the slide that you were on.
Sorry.
Here.
Yeah.
Yeah, the cake. Because this stack lays out it visually lays out the stack here, and there's also a lot of discussion around the FAT protocol thesis and the FAT application thesis. And this has kind of like been the mode of like this value accrual conversation before modularity. So like, just to close that loop, do you think there is an accrual like to the applications? Do you think it flows down to the protocol? Or do you think modularity blows up that mental model and there's really no more like one directional flow of value?
I mean, maybe more the latter, but it's like, okay, it's worth looking at this chart here too. So I think that applications should make money off of user order flow, and they will because they're closest to the user. So like if MetaMask is going to charge a 1% fee to swap or bridge in MetaMask, that's going to accrue to the MetaMask application. If Uniswap in their front end, if the Uniswap website is going to charge fees outside of the protocol level, that's going to accrue to Uniswap. But then like if there was a Venmo made for this too, Venmo might charge a fee and it's their order flow and they're going to take money there. And that makes total sense to me. The solver layer looks a lot more like high frequency trading, where it's hyper competitive, and we want it to be hyper competitive, but like these guys are competing to be the lowest cost provider of their solver services. And it's better than HFT because there's permissionless entry and lower barriers to entry. But I think the solver layer is going to be hyper competitive, but it's not like at a loss. Like it's going to the solvers are going to make the money required to run their business with like enough to pay salaries and run their computers, right?
Yeah.
The settlement layer, I think there's also going to be competition at the settlement layer. We're not going to be the only one, but I think that there can be some degree of scale, some degree of network effects, some degree of like trust too, and some degree of us having our own competitive advantage at doing that part really well, where value can get extracted there. So I don't know if that's like, in a sense, the settlement layer is sort of like a fat protocol-ish, but because it's doing this like cross-chain communication thing efficiently, it's kind of hard to replicate, right? But I think in this layer, every layer is going to have their own value accrual in proportion to the value they provide to the user.
Got it.
Okay, wait, just to where were we? So we did the cheap. So I was making the point here that this goes back again to the value accrual bit. Generalized message passing is important, but I'm just of the opinion that not that many messages are going to get sent between blockchains, because we're going to be doing this intent thing on top, and we're going to batch settle them. So the idea of like a cross can scale to send $1 billion between chains by sending 150 messages a day, right? Whereas if you wanted to do that with a message-centric bridge design, you'd be sending like 10 million messages, and that sounds extremely expensive to me. That sounds like it's just going to cost a lot of money. So then I just said like our vision here. So, and this is a good recap a little bit of what we were talking about. At the intent layer, we want to help applications build efficient RFQ systems for their intents. So they're able to generate, here's the user action, here's what the user wants to do. They're going to run an auction for solvers to compete, and they might take a cut, they might take a fee, the application. And we want to like help them do that, because I think that's still how applications could capture value and how users are going to get the best fill. At the solver layer, we want max competition at the solver layer. This is just going to be like whoever can deliver this service the best deserves to get paid. And one of the things we're working on establishing is a standard for cross-chain intents, so that every solver, it's easy for solvers to join this network because there's a standard for what a cross-chain intent looks like.
And then real
yeah,
quick on that one, if you don't mind. We talked a lot about basically cheap, fast, secure cross-chain intent, cross-chain communication between basically a lot of like the big chains, and across is currently all on like the big roll-ups and Ethereum. Kind of just to set you up here, do you believe that we see a future of like thousands of roll-ups, or at least hundreds and hundreds of different chains? Is that something that you like are body to?
I'm bought into it. Yeah, I'm bought into the idea that like I don't necessarily
appchains and these things.
Yeah. I don't necessarily think that running your own app chain will be like running your own like server. I think it'll be a little bit more involved than that, or a little, maybe not more work, but there'll just be fewer use cases. But I do think it's going to be like point and click deployments for app chains, and there will be advantages to running your own environment. And if Interop is solved here, where it's, you know, not even a penny to move between chains, it's like a 0.0001 cents, and it takes 200 milliseconds, which I think is very possible, then there's really no reason why you wouldn't do this so often.
Yeah.
So I do think that there will only be a handful of general purpose rollups that exist. Maybe,
Yeah.
3 to 10 general purpose rollups end up being the ones that win. And then application specific rollups, there will be many, many. I am a believer in that. And this fits with what we're trying to do here, right? Where if we establish the standard for cross-chain intents, we have this deep solver network. It can just sort of be the infrastructure that like abstracts away sending value between these chains and just makes it happen quickly and beautifully.
Right. And I think that's where you're getting to with this vision. Obviously, intents in the RFQs, they're quite faster, quite cheaper, which is kind of what we've established, and even more secure than some of these other GMP platforms. The issue that I'm kind of seeing and that I can't really get over is how are we going to support solvers and market makers needing to add every single new app-specific rollup, general purpose rollup? How are they going to add support for all these new chains permissionlessly, right? Without a ton of dev tooling, a ton of BD. Like, how does it cross go from where it is now to supporting 1,000 chains without freaking you having to get on the phone with every chain and being like, hey?
Well, no, I mean, Andy, really good push, right? And it's something we're actively working on. But like, first of all, a standard for intents helps a lot because we're basically like, okay, solvers, like, just listen to this, right?
Right.
And then what we also require and what we want to be very fast deployments to any roll-up ecosystem we know about. So if you're a standard OP stack deployment or a standard Arbitrum Orbit deployment, you could have a cross like day one. That makes sense. If you're going to go do a bunch of like custom code and all that like in your own roll-up, then yeah, it's going to take you longer to get that support. But that's probably why people won't want to do that, because there's real trade-offs and maybe not a lot of advantages. Those should be special cases. So it's like, it's kind of just evolving standards and best practices that then make it really easy for infrastructure to support something day one. Not dissimilar from like the EVM. It's like each rollup doesn't have its own execution environment because like there'd be no tooling for it. All these rollups have standardized around the EVM, and then it's mostly easy to transport the tooling to different rollups because they all support a common execution environment.
So there's a world where like Across or the cross-chain intent standards, which Across has co-created or created amongst other participants, is like a part of like rollups as a service platforms, or is a part of like the stand-up building platform for a Arbitrum Orbit chain or an OP stack like a base L3, or like even like a ZK sync ZK stack L3, basically hyperchain.
Yes. Yep.
And you don't foresee a lot of dev work or big trouble or big like coordination to make that happen. It's something that is able to be done potentially quickly and easily and scalable.
Well, the dev work is like some of the work we're doing, right? By building Across in such a way that it makes it no work to turn on another rollup.
Beauty.
All right. So the bottom layer, the settlement layer, we've talked about this, but in the summary, like we want Across to be this cheap, secure, efficient settlement layer for cross-chain intents. And there will be other settlement layers, I'm sure, but if we can be the cheapest and most efficient way to settle these cross-chain intents, we think that's of a lot of value to us. So it goes back to the slide, like what our vision for the Interop stack ends up looking like. Yeah, and that's my talk, guys.
That's awesome. I'm feeling bullish on Across.
I said Across quite a few times. I also said intents quite a few times. Did I pill you? How'd I do? What's the takeaway?
I'm Across pill for sure. We didn't say modular very many times, so maybe I'll try first, and then Hart, please jump in. Like I think it's really cool. When I think of modular, I think of unbundling. And I know Andy's got his perspective on modular as well. It's about optionality. And I think it's really cool to see the two cross-chain functions unbundled. Like we unbundle the interop into the slow path and the fast path. One is for messages, one is for value. And I think that's really cool to see. because it means that we can get the best of both worlds, which is secure messages and fast and cheap value transfers across chains.
I agree with that fully. And I mean, some of these are new ways that we've even thought about how we conceptualize our product. But the unbundling the urgent part of like filling a user ASAP from like the complex part of how do I trustlessly transfer between trustlessly message between blockchains, that is an unlock for us. And so like that unbundling is real. So unbundle the value transfer from the generalized messaging. And like Ravi, to go back for a second, you know, about a year ago, maybe a little bit more now, all of these like bridges were all trying to talk about generalized arbitrary messaging. That was like the move. It's like, oh, how are you doing arbitrary messaging? How are you doing like, and we actually didn't. And I give a lot of credit to my team, particularly Ryan on our team is kind of the product lead for Across. He's like, we're focusing on value transfer because it's a big enough problem that we need to do it itself optimally. And I think that was that's been very huge for us, where we focused on we've unbundled one part of the interop problem, and we actually think it is the biggest part of the interop problem, and we're trying to do it better than doing the whole stack all at once.
Yep.
Yeah. I mean, kudos to you guys, because like everyone else is thinking like, well, it's zeros and ones, right? Information is value, and you know, whether it's value or a message, it's the same thing, but it's not. And you guys thought deeply enough about the problem to realize that there are nuances and differences for the different types of messages, the ones that contain value and the ones that don't.
Yeah, thanks, man. Appreciate that.
Yeah, congratulations on making it through the grill session of Modular March. You've done great, Hart, and thank you for coming on.
When I'm off the air, you guys can score me and like say like, yeah, you know, a little underperformance there, a little did okay there. But no, Andy, Robbie, thank you for doing this. Thank you for doing Modular March. Thank you for educating the space, and thanks for having me. It's really fun.
Cheers, buddy.